Hi, good morning, everyone. Today we are going to solve the problems on Thevenin's theorem. Okay. So, coming to the first problem, already in the first part we explained how to solve the Thevenin's theorem and what is the procedure behind it. Now, let's try to solve more problems such a way that it will be very simplified for you. So, this is the network given to us and is asking find the Thevenin's voltage across AB terminals and also find R internal and calculate both VOC and R internal. So you see this is the circuit diagram given to us. So the first step we know the result. The first step we have to find out the open circuit voltage, and we need to find out the second step is nothing but finding out Thevenin's resistance, or which is also called as internal resistance across the terminals AB. So he has asked only to find out VOC and R internal. Is not asked any load current. So this is a load. So in order to confuse you only, so he has been marked the terminals A and B, and he has been given a voltage source to make you confused. But nothing to confuse. We need to find out the first part is open circuit voltage, and second part is we need to find out the Thevenin's resistance. Let's try to solve the first part, finding out open circuit voltage. So how to find out open circuit voltage is first remove the load resistor. Okay, so this is the load resistor given to us. So this is the load resistor given to us. Remove this load resistor and try to find out the voltage across it. When you remove the load resistor, so this is going to act as an a voltage source like this with 5 ohm, and it is going to have a current source of 2 amperes, current source of 2 amperes. So this is going to constitute the voltage of V volts and 5 ohm. Here you are going to have a resistor of 2 ohm, and this resistive branch is open circuited. Whenever this is open circuited, the voltage created at this terminal is plus VOC, and this is of 0 volts. So now we need to find out the open circuit voltage. So how to handle this problem? So when you see this problem, so here we require the voltage where that voltage is called open circuit voltage, and you can see here. So since it is open circuited, how much amount of current will flow in this branch? Since it is open circuited, the current in this branch is 0. So whenever the current is 0, what is the voltage at this point? So you can see here the voltage at this point, V is equal to I into R. So I value is 0 and R value is 2. You are going to get how much voltage? 0 volts. So 0 volts means you should consider that voltage is, I mean the drop is 0. So you are going to redraw the diagram. So you are going to get a 10 volt source, and here you are going to get a 5 ohm resistor, and here you are going to get a 2 ampere source, and these two terminals are shorted, and here you are going to get the open circuit voltage. See here the open circuit voltage at this point and the open circuit voltage at this point, both are same. Why? Because there is no drop in between these 2 points. That's why the open circuit voltage, if you find at this point, is nothing but the open circuit voltage at this point. So now let's try to apply nodal analysis to find the value of VOC. So how to apply the nodal analysis? So when you see this, so apply the nodal analysis. So when you apply nodal analysis at VOC, you see how many entering currents are there. One is entering current. I am marking this unknown current as some I1. So how many entering currents are there? So there is only one entering current. 2 ampere source is entering, and what is the leaving current? So this is leaving, and you see here the current leaves. It doesn't leave. Why? Because current is already 0 here. So the next current is I1. So I can write down 2 is equal to I1. So how to write down I1? So I1 can be written as current is leaving. What is the leaving polarity of the voltage? This is nothing but VOC, and the current is flowing like this: VOC minus 0 divided by R. What is the, sorry, VOC minus, what is the, you have one more drop here, minus 10. VOC minus 10 divided by the, what is the current in that branch? 5 ohm. So from here I can write down 5 into 2 is 10, and this is minus 10. This will come like this. This is nothing but plus 10. So this is equal to VOC. So now we are going to get the VOC value as 20 volts. So now we got VOC is how much? 20 volts. So the second step is nothing but finding out R internal. So how to find out R internal? Already I explained in the previous classes the procedure of finding R internal. You can see here, this is an voltage source, this is an current source. If you have an voltage source, replace that independent voltage source. So I want to make this voltage as 0. How we can make this voltage as 0? So just by short circuiting it. So when you have an current source, as per the given problem as 2 amps, replace this current source with, so this is of 2 amps, and make this current as 0. How to make this current as 0? Just perform open circuit. So this is applicable when you have two types of sources. So when you are trying to solve it, so as you can see here, this network can be redrawn like this. So here you are going to have an short circuit. So here you are going to have a 5 ohm resistor, and here you are going to have an open circuit due to current source, and here you are going to have a 2 ohm resistor like this. So this is of 2 ohm, and so this is the resistance seen from the open circuit terminal, which is nothing but called as a Thevenin's resistance. So you can see here the current starts flowing across 2 ohm, and current will come to this node, and current will not flow in this branch. Why? Because it is open circuited. The same current will try to travel. So you can see here the current traveling is in which connection? Series connection. I can say that these 5 and 2 are connected in series connection. Therefore, the resultant resistance you are going to get like this. So, where this is called the Thevenin's resistance, when these two are in series, this is 5 plus 2, which will constitute 7 ohm. So now you got the value of 7 ohm. So now this is nothing but 7 ohm. Okay. So this is what the question asked. Find the Thevenin's equivalent circuit. So this is the required equivalent circuit. Hope you are able to understand. So first procedure is finding out VOC. In order to find VOC, I have been removed the load, and I have been marked that voltage as VOC, and the current in this branch and is 0, and resistance is 2 ohm, and automatically this will act as a short circuit. The voltage at this point will be shifted to this point, and this will constitute an open circuit voltage. I applied nodal analysis, and I determined the, so entering current is 2 amperes, leaving I am writing it as VOC minus 10 divided by 5. So I had find out the value of VOC. Second step is finding R internal. So this voltage source has to be short circuited. This current source has to be open circuited. I found, and the remaining elements are 5 ohm and 2 ohm. And you can see here the current in these two branches is same. I can say current is constant or current is same. I can say these two branches are connected in series. The resultant resistance is 5 ohm. So by resubstituting all this, so this is your required equivalent circuit for the first problem. So like this, if you solve more problems, things becomes very clear. Let's try to handle the second numerical for make you to understand more. So come to the second problem. So here the second problem given to us is like this. For the circuit shown below, find the current through RL. So he is asking us find the current through RL using Thevenin's theorem. So we can use normal methods, but he's asking find it by using Thevenin's theorem. So this is how we are going to find out it. So the network given to us is like this. So we have an 10-volt source, we have an 5 ohm resistor, and we have an load resistor where this is nothing but RL, which is given as a 10 ohm, and a current source is given to us where this current source I naught is equal to 2 amperes. He is asking us to find out the current in this branch. So find the current IL in this branch. So he require this current IL. So how to apply? Let us try to see here. So already we know that the procedure of finding it is, so first we need to find out the open circuit voltage, which is VOC, and then we want to find out next one is nothing but the Thevenin's resistance. This is second step, and replace the load resistor. So what is the load resistor given in the problem? So the load resistor given in the problem is RL is equal to 10 ohm. Okay, so we need to find out the IL as by using the formula. So the first step is finding out the open circuit voltage. So how to find out the open circuit voltage? So this is the load resistive branch given. First remove the load resistive branch and find out the voltage later. Okay, so here we are going to have a voltage source of 10 volts, and here you are going to have a resistor of 5 ohm, and this is open circuit. We have removed the load, and this will act as an open circuit voltage, and here we have one more current source which is nothing but 2 amperes current source. So from this problem we need to find out the open circuit voltage. So how to find out this voltage? It's very simple. So when you see this problem, let's try to apply. So in order to find this VOC, let us try to apply nodal analysis at VOC. So when you see here, one branch current is entering. So let's try to mark the current is leaving in this branch. So in order to apply the nodal analysis, we need to apply the Kirchhoff's current law. In this Kirchhoff's current law, how many entering currents are there? 2 amperes current is entering, and the current leaving current is this I1. So this nothing is equal to I1. So I can write down this as 2 is equal to I1. How to write down the current I1? So I1 I can write down it as VOC minus 10 divided by 5. So from here 5 2's 10 minus 10 will be plus 10, that is equal to VOC. So from here if we calculate, we are going to get the value of VOC is equal to 20 volts. So this is the first step. We have been got VOC is equal to 20 volts. So this is method 1. If you want to solve by second method also, you can employ here. We require only the voltages. Okay. So what is the current in this branch? So when the current is flowing, what is the current in this branch? 2 amperes current is flowing. So we have one voltage source. This is of 10 volts. You have an resistance for this branch. This is positive. Current is entering, leaving. This is of 5 ohm. And how much amount of current is flowing into this branch? 2 amperes current is flowing, and we have here VOC. So I want this voltage. Okay, so try to apply Kirchhoff's voltage law. So when you apply the Kirchhoff's voltage law, here you can see here current is leaving. What is the leaving polarity of the voltage? Which is nothing but plus VOC, and current is leaving here minus I into R. I is 2, R is 5, and current is leaving, the leaving polarity is minus 10 equal to 0. So VOC is equal to 20 volts. You can see here both the answers are same. So this is how we can find out the values of VOC by using method 1 and method 2. Let's try to So find out R Thevenin. So when you come to finding out R Thevenin here, so second procedure is finding out R Thevenin or R internal. So this source is an voltage source. So 10 volts is an voltage source. Replace this voltage source as V equal to 0. How V will become is 0? You make this voltage source as an short circuit, and a current source is given to us. What is the amount of this current source, which is nothing but 2 amperes, and make this current source as 0. So how to make this current source as 0 is just make this current source as open circuit. So when you perform like this, how we are going to get the network? So you are going to get the network like this. So this should be short circuited and this should be open circuited. So I'm going to get 10. This is short circuited, and here I have 5 ohm, and this is already open, and here I'm going to have open circuited, and between these two branches I need to find out the Thevenin's resistance. You see here, current will start flowing in this branch and current will not flow in this branch. Why? Because current is already 0 since it is open circuited. Here it is offering 5 ohm. The current starts flowing across the 5 ohm and it flows across this branch and it will try to close it. You can see the current is flowing only across 5 ohm. So therefore the resultant resistance offered by the network between these two elements, which is nothing but R Thevenin is equal to 5 ohm. So now try to substitute. This is 20 ohm and R Thevenin is equal to 5 ohm. So you need to find out the value of IL. How to find the value of IL? So IL I can find out. IL is equal to, so the current is leaving. What is the voltage at this point? Which is nothing but 20 volts. So 20 volts minus 0 divided by 5 plus 10. 20 volts divided by 5 plus 10. So the answer is 1.33 amperes. So this is the resultant answer. If you want to review the session, you see here, first step is finding out a VOC. So I have been removed the load resistor and I want to find out the open circuit voltage. So what I am going to do is I am trying to apply the nodal analysis. I have one entering branch and one leaving branch. Entering branch is 2 amperes, leaving branch is I1. So how I am writing I1? VOC minus 10 divided by 5, you are going to get VOC. Second step is, so short circuit the voltage source and open circuit the current source. This is nothing but since the given source are independent sources, then automatically what will happen is so these are the two branches what we are going to have. So here it is open circuited and one is short circuited. So current will try not flow in, current will start moving from here. It will not flow in open circuit branch. It will try to close of its own with the 5 ohm. So you got the values of VOC and I was just substituting the formula. So the formula for this you can also write down VOC minus 0 divided by R Thevenin plus RL. So just as I substituted in the formula to get these values. Okay. So this is how R Thevenin plus RL. Okay. So that's how you are going to get these values of 1.33. Hope you are able to understand the problems. Let us try to solve one more category of problems. Coming to the third problem. So let us try to solve the third problem. So here find the current across, find the current IL across a 10 ohm resistor using Thevenin's theorem and determine its power losses. Okay, so he is asking us to calculate its power loss. So the network given to us is like this. Okay, So we are having a network with a current of 2 amperes, and you have one resistive branch like this, and you have one more branch like this, and you are having a 10 ohm resistor, and you have one more resistive branch and a 1 ohm resistive branch with an current source like this of 5 amperes, and this is going to have 2 ohm, 1 ohm, and this is the RL given in the problem, which is nothing but 10 ohm. This is of 1 ohm and this is of 2 ohm. So this is what is given in the problem, and he requires the current in this branch. He requires the current in this branch. This is what it is asked. Find IL across the 10 ohm resistor. So as per the procedure, you know that first we need to calculate two parts. First one is find out the open circuit voltage, and the second part is find out the Thevenin's resistance. This is finding out the first part. This is finding out the second part. And you have a network like this. Replace the same network and write down this given value. The all are given in the problem is 10 ohm, and we need to find out IL here. So how to find out the IL? So whenever the current is leaving, what is the voltage here? This is nothing but plus VOC. So IL I can write down it as whenever the current is leaving, what is the voltage you are going to have? So voltage is equal to plus VOC. So it flows from high potential to low potential. VOC minus 0 divided by R Thevenin plus RL. So we need to solve step 1 and step 2, and you substitute in the direct formula, you'll get it. Okay. So first step is finding out the open circuit voltage. This open circuit voltage and relabeling it as VAB, and I'm indicating it as VA minus VB. So I have to find out the voltage at A, and I have to find out the voltage at B. I'm redrawing this network. So I'm having an current source of 2 amperes, and I have an resistor of 2 ohm, and I have an current source of 1 ampere, and here the load is open circuited, and here I have the one more 1 ohm resistor and 2 ohm resistor followed with a 5 ampere current source. This is a 5 ampere current source. So we need to find out V A, and this is VB. So the difference, if you find out, we'll get this open circuit voltage, or the voltage between these two is called open circuit voltage VOC. Now let us try to find out VA and VB. So I'm trying to solve in two parts. So I'm going to apply the nodal analysis at this point. So apply nodal analysis at which node? VA node. Similarly, apply nodal analysis at node VB. So here you can see here how many entering currents are there. So what is the voltage at this point, which is nothing but VA. What is the voltage at this point is also VA. So how many entering currents are there? Only one entering currents are there. Later I am assuming the remaining branch currents as some I1 which is leaving, and I2 which is also leaving. So 2 is entering and it is leaving it as a I1 plus I2. So 2 is equal to, how to write down I1? So the polarity when it is leaving, the polarity is VA. So VA minus 0 divided by, what is this branch resistance? 2 ohm. So here it is VA minus 0 divided by 1 ohm. So when you start solving it, so you are going to get 2 is equal to VA by 2 plus VA by 1. Take VA as common. 2 is equal to VA 1 by 2 plus 1 by 2, which is nothing but 1.5. So from this resultant we are going to get the VA is equal to 1.33 volts. This is the first step. Now coming to the applying nodal analysis at node B. So here we have node B, we have to apply the nodal analysis. So to this branch, already 1 ampere current, I mean 1 branch current is entering, and I am marking this as some I3, the current in this branch. So how much the current is entering? So entering currents 5 is equal to the current which is leaving is nothing but I3. So 5 is equal to, you can write down this I3. So how to write down I3? So high potential VB minus 0 by 1. Therefore VB you are going to get it as 5 volts. So we require VAB, which is also called open circuit voltage, which is VA minus VB. So that VA minus VB is 1.33 minus 5, that is equal to 1.33 minus 5, we are going to get minus 3.66 volts, is nothing but your open circuit voltage. So this is your open circuit voltage. So you got this VOC is equal to minus 3.66 volts. So second step is finding out R internal. Already it is told, if you have voltage source, replace the voltage source with short circuit, and if you have current source where the current is of 2 amperes in the problem, make this current as 0, which is also called deactivation. How current will be 0 is try to perform open circuit, redraw the same network here by applying this concept. So we have a 2 amperes, this is acting as an open circuit, and we have one more branch here, this is of 2 ohm, and you have one more branch here, this is also of 1 ohm, and here you have been removed the load. So the resistance seen from the open circuit terminals is called Thevenin's resistance, and here you go, you have one more 1 ohm resistor, and here you go, you have a 2 ohm resistor, and these two terminals are open circuited. So when you see here, so the current starts flowing and current is dividing. So I can say that if you want to mark, you mark this as 0, you mark this as 1, you mark this as 2, and you mark this as 0. So between 1 and 0, you can see here current is entering, current is dividing, then these two branches are connected in parallel. So when they are connected in parallel, so you can calculate 2 into 1 divided by 2 plus 1, and you have this like this, okay, and this is 1, and you have the second node 2, and between these two we have to calculate R Thevenin. See here, the current will start flowing in second node, and current will not flow in this branch. Why? Because current is already 0. The current in this branch is only 1 ohm. So you have an 1 ohm branch. So when you find out this 2 into 1 and 2 divided by 1, you are going to get this value is 0.66. Okay. So now I can say 0.66 and 1 ohm are connected in series. So since current starts flowing like this, I can say these two elements are connected in series connection. Therefore, between 1 and 2, you have 0.66 plus 1, which is 1.66 ohms. So this is 1.66 ohms. So from here, you are going to get VOC is how much? VOC is minus 3.66 minus 0 divided by 1.66 plus 10. So when you divide it, find this value, then you are going to get the current as minus 0.313, which is traveling from in this direction clockwise. So the current you got it is 0.33 amperes. Now for example, if you consider this is traveling in which direction? Clockwise direction. If you take the current is flowing like this, okay, if you assume the current is flowing like this, so this is the IL which is flowing. So if you take the current is flowing in opposite direction, this will be plus 0.313 amperes. Hope you are able to understand the problem. So I repeating the problem again. So remove the load resistor and you will get VA node and VB node. So VA and V both are of same node. So apply nodal analysis. Entering is 2 amperes. VA minus 0 by 2. VA minus 0 by 1. So you can find out the VA value. So coming to here, the voltage at this point both are same. So you can have one entering branch and one leaving branch. So 5 equal to I3. How to write in I3? VB minus 0 by 1 if you write, then you will get VB. Then you take difference of this voltage. So this is nothing but which voltage? Open circuit voltage. Then you are going to get VA minus VB. You are going to get this voltage. Next, I already discussed how to find out R Thevenin. So if a voltage source is there, replace with short circuit. The current source is there, replace with an open circuit, and find out R Thevenin here. So when you find out the current is entering, the current is dividing, I can say these two branches are connected in parallel and you have only this branch. Why? Because the current doesn't flow in this branch. These two are in parallel, you will get it as 0.6 and this is in series. And again you can take the current will try to flow in this branch and I can say the current is constant. Whenever the current is not dividing or the current is constant, I can say they are connected in series. Substitute these values in the equivalent circuit of VOC and RThevenin, then automatically you can get these values. Hope you are able to solve the three examples in this problem. In the next class, we'll try to solve the bridge network, which is very important in gate point of view or in competitive exams. If you feel the video is useful to you, just give an like and share to your friends and subscribe to the channel, which will help us or motivate us to do more channels, to do more videos and to create more content. Thanking you, yours Ram.